Okay, so today we're talking about scientific notation. And what is scientific notation? Why is it used? Most commonly, it's an easier way of writing very large or very small numbers. So if you're taking notes, and you might want to start with this. Okay, so scientific notation, let's just take a look here. This is an example of, a fairly long number. We've got 9 digits here. And you could write this in, sort of standard common notation, and that's the way you would write it. But in scientific notation, you can write it like this. Now, there's a few differences that you need to notice, okay? First of all, when we write in scientific notation, we only use the significant figures in the number. So notice that there are 6 sig figs here, because these 3 zeros are just placeholders, so they're not significant. And when we write it in scientific notation, the significant figures are the ones that we use, and you have to use all of them. The second thing that you'll notice is that the decimal is placed always after the first sig fig. So the first, really it's the first non-zero digit. It's always after the first one. It's never after the second, third, or fourth. It's always after the first one. So we use all the significant figures, and we place the decimal right here. That's the first 2 steps, really, in writing in scientific notation. The other thing you'll notice is that we have times 10 to some power. Now this times 10 is an important feature of scientific notation as well. So that's the third thing you want to make sure you have in scientific notation. The exponent. So now finally let's talk about the exponent. The exponent is there to indicate sort of how many decimal places you would move this decimal from this position. So if you have an exponent of 8, that's how many decimal places you would move that decimal to get to the original number. Another way of looking at it is literally, kind of the way that this shows. And let's just see if I can, here's my pen. So if we take a look at this, like the times 10 to the power of 8. What's 10 to the power of 8? Well, that's 1 followed by 8 zeros. Right? 100 million. So if we multiply this by 100 million, what do we get? 1.73219 times this number right here, we should get this number back. Okay? So it's basically it's showing a product, a smaller number, times a larger factor of 10 always. And the shortcut is moving the decimal place this many spaces. If it's positive, if it's a positive 8, we move the decimal place to the right. Okay, 8 spaces to the right. So we were here, right? The decimal point's there. 1, 2, 3, 4, 5, 6, 7, 8, and that's your number. Okay. Now, if the decimal is a negative number, so let's take a look at this: 1.5 times 10 to the negative 3. Well, you could view that as 1.5 as a number times, what's 10 to the negative 3? Well, it's this number right here. That's what 10 to the negative 3 is. That's 1 over 10,000. And if we did that, we would get an answer of that. Okay? Like I say, if you do that on your calculator, so here we go, on the calculator, get that going here on, let's clear that off. So 1.5 times 0.001 is this number right here. So that's what you get. Now, if you're looking at scientific notation, and you kind of view this as the shortcut, this negative 3 as a power of 10 tells us to move the decimal place 3 spaces to the left. So see how you get that number? So this decimal place would go 1 space to the left and 2 spaces to the left. What do you put in there? You put a 0 in there. And 3 spaces to the left, you put a 0 in there, and boom, there's your decimal place. So you have 0.2015. So if you have to move the decimal place over and there's no numbers there, you fill that space with zeros. Okay, and it is pretty common, and it's expected that you put a 0 in front of the decimal too, because if you just write this, sometimes that decimal can be really faint and it looks kind of funny, and they're wondering what you mean. Is that just another way to write 15, or what do you mean? So put a 0 there, and there's no question. Okay. So to finish off the notes there, if you put the exponent there, if it's positive, you move it the decimal place to the right. All right, so let's do some practice then. Let's do some practice on that. Let's get to the full page here for you. All right, so here we go. Let's do 5.33 times 10 to the power of 5. Okay, so just take a moment and you write down the answer, okay? And I'll give you the answer in a few seconds. So there's what you should have had for your answer, right there. So don't put a decimal place there, okay? Don't put the decimal place there, but that's where the decimal place is understood to be. You wouldn't put a decimal place there because then it would look like someone might look at this and say, oh, he's trying to say that there are 6 significant figures when really there are only 3. Am I still frozen up there? Apologies. My freeze button on my screen is a little bit touchy sometimes. Okay, so you wouldn't put the decimal there, but what you would do is you would say, okay, 5, positive 5 means I go 1, 2, 3, 4, 5. Fill those spaces with zeros, done. See that? Okay. How about this one? 3.9901 times 10 to the negative 4. Okay? So take a moment and write that as a common notation number. Okay, so there should be your answer, something like that. This number right here, the exponent, is a negative, so that means that this decimal has to go back 1, 2, put a 0, 3, 0, 4, 0, boom. See that? So that's your number. And yes, you do need to include all of these digits. All of these figures are significant because they were in the original notation. Okay? So this negative exponent represents a very small number, less than 1. And a positive exponent represents a number that's greater than 1, or greater than this number here. Right? Okay, questions? You good? All right. So let's go the other way around. Let's say I'm going to give you a number and you write it in scientific notation, because that's a bit of a different ballgame there. Okay, so here's a big number like 3, 4, 5, 6, 7, 8. And I want you to write that in scientific notation. So go ahead and do that. Okay, did you get that for an answer? Oh, I guess. Oh, my freeze button didn't work again. So you guys are all watching me write that up there. Okay. That didn't help. I was wondering why a lot of you were looking at the screen there and like, oh, they can't see this. What are they looking at? Apparently they can see this. Okay. Does that make sense though? Did I do that right? How about, let's put it this way. Did I do that right? Yeah. Okay. Let's just check. So I would put the decimal place there, which I did, okay. And that decimal place would have to be moved 1, 2, 3, 4, 5 to get this original number back, and there we go, 5. Good? Okay. Don't do this, okay? Some students have done this in the past. Don't do that, because that's not the same. Right? That means that this number 3.45678 is multiplied by itself 5 times, not multiplied by a power of 10. You know what I mean? So don't forget the times 10. Really, really important. Okay. All right. Let's try this again. I'm going to give you one, and I want you to put it inside of notation. I'm going to freeze the screen so you can't see it, and we'll see if that works. Okay? Here we go. Okay? I like 3, 4, 5, 6 apparently. There we go. Let's see. Okay, is that correct? Yeah? Okay, did you guys get the same answer? All right, let's just check and see if that's right. So the significant digits, I'm going to write the significant figures first, which are just these ones, right? So I wrote those down right here. I put the decimal after the first one, right there. Then I have to count backwards. See, there's the decimal place over there in the original number, so I have to count 1, 2, 3, 4. So 4 spaces to the left to get my original number, 4 spaces to the left. There we go, scientific notation. Got it? All right. So you guys are pros now at this, scientific notation. Got it all figured out. You can go either way. All right. So how old are you in scientific notation? How old are you in scientific notation? You can go and just shout it out if you know. Sorry? 1.6 times 10 to the 1? I like it. Yeah, it's good. And yeah, you can put the 1 there in scientific notation. So if you're 16 years old, that's 1.6 times 10 to the 1. Now, here's a case where scientific notation really doesn't make your life easier, right? Because 16 is really easy to write, but 1.6 times 10 to the 1 is not so easy. But this is just saying that you can write any number in scientific notation. Okay. What about this number? 5. How do I write that in scientific notation after this format here? You don't. Well, what are the significant... Well, you can. Yeah, you can. I don't know why you would, but you can. Okay? So what are the significant figures in this number? Just 5. Okay? Now, as far as the decimal goes, if there is only one... You don't have to do this 5 point, because you can't put any numbers behind there. You can't do 0. Why? Because now that's 2 sig figs, so you can't add precision when you're doing this. So what you want to do is just leave it as 5. The decimal is understood to be there. Because we're not changing the number, what power of 10 would I multiply this by? Very good. 0. Because do you remember that 10 to the power of 0 actually equals 1? Right? So it's like 5 is the same as 5 times 1. Whoa, profound. Isn't that profound? Mm-hmm. So you could say, yeah, I'm 1.6 times 10 to the 1 years old, or your little sister or little brother, if you have little brothers, like, hey, happy 7 times 10 to the power of 0 birthday. They would think you're pretty strange, but you could do it. 7 times 10 to the power of 0, what? Okay. Anyways, as we continue on, so length in these SI-based units, the length is the first one. The distance between things, we have length, the unit is meter, the symbol is m. That one's pretty standard. As we continue on with the other quantities that exist in the world, time is another quantity, okay? Time. I don't know where it is in your fill-out sheet. I don't really care. If it's not, yeah, just fill it in an empty space there. Okay. So time, the standard unit for time is the second, and the symbol is s. Okay, that should be pretty straightforward. Another quantity is mass. Okay. Okay, we've talked about how long something would be, how much time something takes, and of course now we want to talk about the mass, the amount of substance that's packed into it. The kilogram is the standard unit. Okay, not just the gram, and you might think, hey, meter is a standard unit for length, why not gram? Well, gram is actually super small. Like, it's really small. And so we're talking about your mass in grams, okay? We're talking, thousands, 50,000 grams. Well, that's not, 50 kilograms might be a little bit better, right? So it's kilograms is the base unit there. And kg, notice lowercase, okay? All these are lowercase here so far, kg. We good so far? Questions? Go? Good? Okay. So length, time, mass, volume, okay, might be one you think should be on there, but we're going to talk about amount of substance. This is probably fairly new, okay? So this is not really like volume. Actually, volume technically is a derived unit, which means that you can express volume as one of the other base units, and actually volume would be length, okay? It would be length cubed.